Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Ellumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Ellumen's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Ellumen's website at www.ellumen.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Hi, everyone. Thanks again for joining another edition of AI Innovation Space. I'm here with my co-host, Todd. Todd, how are you doing today?
Doing well, thanks, Yana. Looking forward to another podcast edition today.
Yeah, I'm super excited about the podcast edition today for quite a number of reasons because the area we're going to be talking about is an area that I have very little experience in as it pertains to the application. And I'm super excited about having our guest, Anshuman Pradhan, here with us. Today I'm going to have Anshuma introduce himself. He has a PhD from Stanford in energy resource engineering. He did some internships with Shell and Andaco, and his postdoctoral work at Caltech. And really excited to get into the conversation today. Welcome, Anshuma. How you doing?
Hi, Anu. I'm pretty good. How you doing?
Good. So we're going to just jump right to it. Tell us a little bit about yourself, some of the things you've done, your past roles, how you got into the machine learning artificial intelligence space.
Sure. Thanks for the question. As you mentioned, I did my PhD at Stanford in energy resources engineering. I have a background in geosciences. My bachelor's and master's degree were in geophysics. In geophysics, we solve a lot of what you call our inverse problems. We have the data. For example, you can have seismic data or gravity data, and you try to infer problems about the subsurface, what's underneath the earth. And so this is a very ill-constrained problem because the data is always low resolution. So, and then you have these multiple types of data, and that is where machine learning comes to help. As part of my PhD experience, I developed an interest for how deep learning and these modern techniques can help estimate these earth properties or what's inside the earth and what is happening inside the earth. And they will have many other applications using machine learning. My experience, I have in my PhD specifically, I have worked with seismic data to better understand the reservoir properties. For example, where you want to store carbon in the earth, or where do you want to drill in order to extract the oil and gas. I've used deep learning models to design methods to estimate this better. As you mentioned, I've had a couple of internships in the oil and gas industry. Two of them were with Shell and one with Anadarko. There, I worked on their real world applications. They have many oil fields in the Gulf of Mexico. And with Anadarko, I worked on a field in offshore Mozambique, where I used this large scale 3D seismic data in order to estimate the Earth's properties. In my postdoctoral work, I kept on continuing this machine learning applications for the subsurface. There, I was working on a groundwater management problem. As you understand, right now, with the climate change and the crisis that we are facing as a humanity together, for groundwater management has become a challenge, especially in California's Central Valley where there is lots of drought. And then what is happening is that for agricultural purposes, people are trying to pump more, and that is leading to lots of natural disasters. At Caltech, I was using spatial machine learning models, especially Gaussian process, and I developed some theoretical models and applied them to real data in order to better manage groundwater. I'm currently working at C3 AI as a senior data scientist, working in the supply chain industry, developing machine learning applications.
That's awesome. So that's
Yeah.
really great, Anshuma. I had a question for you. What are like some of these applications? So you spoke about seismic data, right? I'm wondering why are you guys investigating seismic data? What are you trying to find from seismic data?
That's a great question. So let's say seismic data, right? So we all know about sound waves. And then what seismic data is basically, active seismic data, we send sound waves into the earth and then we record their reflections from inside the earth. Now, how might that be useful? Let's imagine a scenario. Let's say the typical oil and gas exploration scenario. You want to go develop a large, huge oil field which can exist over thousands of squares of kilometers. And then you don't know where to drill, and even drilling a well costs about, let's say, $1 million. And then you don't want to mess up. You want to drill at the right spot, at the sweet spot where you can optimize your production. Now, seismic data, but staying above the ground, you don't know where to drill, right? And that's where the seismic data comes in. What we do is we have some active sound sources, and then we send them, we stimulate the surface of the earth, and we send those sound waves into the subsurface. Now, what will happen is that wherever, let's say, you have an existence of a reservoir, for example, an oil reservoir, your rock will have some material property change. Now, if the property is changing, sound waves will reflect and refract, and then you can record those waves back at the surface. And that kind of gives us an estimate of what is lying. So you can convert those recordings of the sound waves into property of what exists inside the earth. Now, that is just one application. Seismic data has many other applications. For example, earthquake detection and earthquake prediction. Even for these days, when you want, let's say, you want to store carbon storage and sequestration, where you want to store your carbon, seismic data can help you answer that question.
That's awesome.
Great, thanks for sharing, Anshuman. So I have experience myself with these inverse problems in a little bit different area with electromagnetics and estimations, particularly for trying to determine what the properties are inside the skin of like a human or animal. I'm curious, can you go into some more of the details on how you guys were using machine learning to help these seismic estimations? I mean, if I'm familiar with one of your papers you published, Seismic Bayesian Evidential Learning, Estimation and Uncertainty Quantification of Subresolution Reservoir Properties. Could you talk more about some of the data science and AI and machine learning that kind of goes into the inverse problem estimation?
Sure. Thanks, Raul, for the question. So, this inverse, as you mentioned, this is an inverse problem. You have this data, and then you want to estimate something about the property or the rocks that lie beneath the surface. Normally, you have some physics based models. Let's say you know how your sound is propagating in the subsurface. Now you can use that to make an estimate, as you mentioned, like build an inverse model to predict this property. But one of the big challenges that we face is the uncertainty that is there in the subsurface. Because you see these material properties, these rocks that are there in the subsurface, they can have, they are very heterogeneous and their properties can change at very small scales. Now, our typical inverse formulation methodologies that we have developed over the past, I believe, 100 years are kind of quite limited to handle the uncertainty of the scale of uncertainty that we face in these subsurface problems. And that is where we believe that machine learning models can really help. So, for example, let's say in this paper that I worked on, I was trying to predict sub-resolution reservoir properties. So, the seismic data that we have, it has a limited bandwidth. So it can, I believe, it kind of filters out very low frequencies of the sound waves and very high frequencies. So what you see down of the earth down below is a very band filtered image of that earth. Now, what I was trying to, but still, your seismic data can have very minor signatures which can help you reduce this uncertainty. And that is what I was trying to solve. So I explored in this paper, I explored a bunch of machine learning models. I explored unsupervised techniques, for example, PCA and wavelet decomposition methods. I also explored supervised learning methods, for example, deep learning. And then I was trying to use the seismic data and detect this kind of minor, very tiny fluctuations or data signatures that can help us reduce this frequency bandwidth gap that we face quite often in our data. So that's like a very high level overview of what I was doing in that paper.
Okay, great. Thank you for sharing.
Awesome. Also, you mentioned you use PCA. Can you share a little bit on what you did with PCA? I'm familiar with SVD, singular value decomposition. Can you talk about what you did with PCA?
Right. Sure. So to elaborate, to get to the PCA question, let me set up the problem, what I was trying to do. So As I mentioned, we have a lot of uncertainty in these subsurface problems. So we were trying to use machine learning in a way that would help us also make, not just make like single deterministic predictions, but give us a distribution of the properties. So one of the techniques that we used was approximate Bayesian inference. It's also known as approximate Bayesian computation, ABC, in the literature. What it does is that it uses this concept of called summary statistics. So from the data, you extract certain statistics that you feel are useful for this property or variable that you're trying to estimate. So in that context, I was exploring different machine learning models to as summary statistics, and PCA was one of them. So we had this seismic data that is recorded across, let's say it can be a time series data. And then I was using PCA to extract the most significant components of that time series data that would hopefully be informative on the variable of interest. So along with PCA, I also tried other unsupervised and supervised learning models as summary statistics.
I see. Okay. So can you also expand a little bit on the deep learning that we're using? So were you taking the extracted time series data from the PCA and using that as an input to a deep learning model? Or can you talk more about the inputs and outputs from the deep learning model as well?
Right. Yeah, that's a great question. So, as by definition, unsupervised methods, they don't have a target label, right? So, and we were facing some challenges with PCA and some of the unsupervised methods, because even if you extract, you kind of do this dimensionality reduction with these techniques, and you try to extract the most significant components from the data, they might not be informative on this variable of interest that you're trying to estimate. And that is where deep learning really helped us. So what we did was we took the data and then like set up a normal deep learning regression problem. And then we were using that regression model as a summary statistic in our Bayesian inference method. And this kind of helped us give a better informed prediction of the uncertainty. As regards to a question, we tried combining PCA and unsupervised with deep learning. For example, we would do the dimensionality reduction first, PCA, and then use those significant principal components as inputs to the deep learning model. But we found that that did not significantly improve the results. Deep learning just did equally good with the raw data itself. So we felt that in the end, our conclusion was just using deep learning model outperformed all the other models that we investigated in that study.
I see. Okay. Thanks for sharing that. So, another area that you mentioned that you were using machine learning in was this groundwater problem. Can you talk more about what the importance is of that particular problem? Like, what are people trying to solve, and just expand a bit more on what you're doing there?
Sure. So I started. So this was a problem that I was addressing during my postdoctoral work at Caltech. We were collaborating with some researchers from NASA JPL, and we tried to solve this groundwater problem in California's Central Valley. Central Valley is where the majority of the agriculture happens in California, and that's a very water-strapped region. People have been pumping too much water out of the groundwater. A side effect of that, of over pumping, is that if you take out, you can imagine, let's say, the water that exists beneath the subsurface is like a sponge, right? Or if you just push, pump out too much water, and then you have some load on top of it, let's say our building or our infrastructure, then your rocks will tend to compress. There is no water in the pores to kind of keep it in an expanded state. So what that leads to is you see these events of land subsidence. So you pump too much water, your land actually subsides. There are certain parts in the Central Valley where in the 70s, in the 50s, I think the land subsided by over like 50 or 50 feet, and then that can cause significant damage to the infrastructure that you have on the surface of the earth. We are getting better. I think the California's Department of Water Resources had faced lots of problems with regards to this, and they are coming up with better strategies to manage the groundwater. For example, if you predict there is going to be a drought, then you can divert more surface water from lakes or other sources to fill that gap of water scarcity. And that is where we're trying to come in. So we had lots of data there. We had this data from the wells from the farms that we in that area, and they had some pumping information in like time series data, but that time series data is very irregular. So many of them are private wells, and we didn't have continuous data. So those are like very sparse and irregular, noisy data. and those are even scattered across the valley. So we don't have like a spatial coverage was very low. But we also had satellite data which had very good spatial coverage. We had satellite data which kind of tracks the ground, what like the ground movement, how fast is your surface subsiding or not. And basically what we're trying to do is we're trying to relate the two. So the water level in the wells, and then how much your land is subsiding. So if you let's say you pump too much 5 years back, did we see a spike in the subsidence, let's say a few years later? And if we did, what is that relationship? We're trying to model that. In order to do that, we used spatial processes, because as I mentioned, one of the problems was we didn't have good spatial continuity of the data. So we use spatial Gaussian processes to model this relationship between the water levels and the land subsidence.
I see. Okay. Thank you for sharing.
That's awesome. Thanks for sharing. Really great stuff and really great work, Anshuma. I would pivot a little bit and probably start having some conversations around some of the things you've done at C3 AI. So can you share with the audience what does C3 AI do? What are the products and services that you guys offer? And why did you find, from all your energy and resources problems that you've been solving, why did you choose C3 AI as a place to work?
Thanks for the question. That's a good question. I started working with C3 last month, so I'm like pretty new over there. What C3 AI does is C3 AI provides software applications for enterprise scale machine learning models. It works with a lot of different industries. Some of them are the oil and gas industry, the supply chain industry, the defense sector, the reliability industry, like the reliability applications in various manufacturing industries. And C3 AI provides this application suite which helps you develop these enterprise scale AI applications very easily and deploy them at scale depending on the industry you choose. They have been working with this industry for quite some years, and they have developed this kind of turnkey application suites catered to this industry, and they are kind of building on top of that as more customers come in. Beyond my postdoctoral work, like I've been trying to explore machine learning quite a lot. When I started out in my PhD, I started out with a purely geoscience background. Then I went more into the theoretical domain of data science and machine learning. And then throughout all along these years, I have enjoyed developing, writing code and developing machine learning models. One of the problems that I faced in my PhD was, let's say, the seismic data I was talking about. Real world applications can be huge, right? It can be like gigabytes of data. But how do you develop software to quickly process and get to the point of application? That was lacking in my academic experience.
Correct.
So I was really excited. I believe like C3 AI, the kind of application that they develop and deploy at scale for like real world applications really attracted me, and I wanted to gain that experience. So that's why I ended up with them. Another reason is that they also work with some of the industries that I have worked with before. For example, the oil and gas industry and the sustainability industry. So that's also another reason why why I chose C3 AI.
I see. Okay, great. Thanks. That makes a lot of sense. So you mentioned briefly earlier what you're doing on with C3 AI. So what is your current responsibilities like over there? What are you working on day to day to help C3 AI?
Yeah, so I'm working there as a senior data scientist, working in a supply chain industrial project. I'm trying to develop their base product for a process manufacturing industry. So what we're trying to do is, let's say you have a food manufacturing company, and then you have the demand forecast of the various finished goods into say 6 months or 1 year into the future. And then every day you have to kind of come up with a list of, in order to make this finished goods, you have to there are like different subtasks and various intermediate processes that you have to do. How do the workers schedule things? I'm working on this application which kind of helps some of these companies optimize the scheduling different processes for the food manufacture. As a data scientist, what I'm doing is I'm trying to develop their base application package for this optimization. I'm learning different the C3 AI software application platform, and getting like to code hands-on like every day. That is something I really enjoy. I'm really enjoying because I'm getting a first-hand picture of how you have these huge problems, and then how you develop this kind of coding structure in order to handle such huge problems from the beginning. So yeah, that's what I do. I also work with the customer team to understand their needs, and then how we can write better code and better models, machine learning models, satisfy their needs.
I see. Okay. Yeah. Thanks for sharing. That makes sense. So you kind of alluded to this earlier. I know you've only been at C3A a little while, but feel free to also use your previous roles prior to C3AI to kind of help guide this question as well. But yeah,
Sure.
I'm kind of curious. So, how is machine learning helping solve problems with C3AI, and are there particular challenges that you're facing with C3AI products using machine learning? You kind of mentioned earlier these huge real world applications. So anything further you can share on that?
Yeah, yeah. So C3AI, as I mentioned, it's involved in a lot of different projects where, and then like many of almost all of them are using machine learning models. For example, one of the applications is reliability and predictive maintenance in, let's say, the supply chain industry or the oil and gas industry. What they're trying to do is, let's say you have an upstream oil and gas production facility, and then you have numerous equipments, and then safety, these valves and filters and whatnot, and then you are trying to do predictive maintenance. So C3AI is building using machine learning to predict how you can predict ahead of time if an equipment will fail or not, and or if it is showing signs of failure. So it's trying to learn from this time series data of the equipment behavior from the past, and then trying to predict. That's just one application of how machine learning helps this C3AI software suite. There are also other applications in the defense sector where machine learning is trying to like read structure from the data and then predict. In terms of challenges, I feel that this is very common to all the, even like the C3I products and the other problems that I have worked on before. Finding the right machine learning model and then making sure it generalizes to data. And how do you understand? So as is the paradigm in machine learning applications, we always learn, like for supervised learning, we learn from a limited training set. And in real world applications, many times you get situations that are extrapolations from that training set. So I believe we still, like in terms of the theoretical development and also the applications, current applications that are there in the literature, one limitation I feel is that how do you extrapolate to this unseen situations, and will a model that is performing generalizing well to a particular data set, let's say even if with your validation and test data set, you see something completely new from your customers or from your data source, how will that machine learning model hold, and if it will be able to predict the uncertainty that is associated with that extrapolation. I believe that's one of the many fundamental challenges that still exist with current machine learning model development and applications.
I see. Okay, thanks for sharing. You have any questions related to any of that, Yano?
Oh, yeah, I mean, it's going pretty good. The only question I would have is you spoke about, for example, for Shell, right? Is there any way that C3 AI helps Shell to do their work better, right? The reason why I ask this question is, from my understanding, you're also a no code environment. So is it that you guys are connecting with the machine learning scientists on staff at Shell to just basically drag and drop this machine learning elements for use, or are you guys the one really helping them with the other piece of it? Well, you guys are typically helping them with the other piece of it because you're training the models at the back, but are they just dragging and dropping that on their system, or how does that work? I know you
Right.
C3AI is a no code environment, so I was just wondering.
Yeah, yeah, that's a good question. So Shell has its own dedicated team of data scientists. I believe I have interned there, and they have a huge data science team which kind of does this. They're like they have the subject matter experts, and data scientists work hand in hand to kind of develop which model will be right for the problems that they're trying to solve. One of the challenges that they face, as we talked about earlier, was deploying these models at scale. So this Shell has numerous downstream and upstream facilities, and even if they build a model, deploying this model at scale and then which can run real time and make those predictions, let's say for like hundreds of their facilities, I think that is, if I understand correctly, that is one of their limitations that they face. C3AI is providing them products to help deploy these models at scale and then make these predictions. And that is why, like in a way, you can see that as C3AI is digitally transforming sale. In terms of the low code, I believe that Shell collaborates both on the deep code and the low code side. So For especially for the low code, I think C3AI gives them tools for their geoscientists. For example, someone who is not that familiar with the data science principles, they can just take this software suite and then train the models on the fly without having too much expertise of what's happening on the back end. Yep, that's correct.
I see. So thanks for sharing more about how Shell is using both low code and no regular code to work on these models.
It's awesome.
So, you focus a lot on Schumann on better understanding Earth's subsurface and various topics, different roles you've had. I'm curious, Yano and I are curious, what are some ways that you think machine learning can help better understand Earth's subsurface? I mean, even beyond, some of the particular applications you focused on, is there possibly other applications as well, or anything further that you haven't, kind of done in that area that you think would be interesting work in the future?
Yeah, I believe that, like, especially in sciences, like lots of unsolved questions that our current scientific methods and tools have not been able to address. One of them, as I mentioned was earlier, was this uncertainty that we face with subsurface problems, and this uncertainty has like big implications for even for saving lives. Just moving beyond from, let's say, exploring the earth for like production of oil or metals or minerals or like battery metals. Let's say you want to predict earthquakes. I think that's the we still have not we still don't know when an earthquake is going to occur, right? And how do you predict that? One of the fundamental challenges of why we are not able to predict with as much certainty is that we are not able to have like a high resolution picture of the subsurface, right? As I mentioned, you can have this heterogeneity at like very small scales, and then with your data that you cannot go and drill everywhere in the earth to know what's happening or kind of how do you study that physics. I think that is one of the unsolved questions that still exists in this domain. Not just earthquakes, it could be volcanoes and other problems. And as we move into the future, we are talking about decarbonizing the earth. So you will need to store like gigatons of carbon in the subsurface, but where do you store that, and how do you make sure that carbon that is stored is not contaminating other useful sources of water? So those are some challenges, and I believe the biggest problem with them is the uncertainty that we face. Machine learning in the future, in the next few decades, I hope it will be great if it is able to make some progress in answering these questions. We've been doing good. So with my limited knowledge of the literature, I believe that like we are progressing to that, like Bayesian neural networks, Bayesian deep learning network. That's a good direction. But then we need better ways of incorporating physics that we know from our behavior of the Earth, how we can integrate the two, and how we can make better predictions that can help us sustain through the 21st century and also do so in a hazard-free manner.
So I'm just curious, Anshuma, right? Like you brought up a very interesting subject, and I would love to have us talk about it before we wrap up here. But so you mentioned that the path towards being able to predict earthquake is still slim, right? But is it even possible? Is it going to be humanly possible to do that, given your knowledge on material, energy resources, earth, and all that?
Yeah, that's a great question. Normally, like we have, let's say you have a seismology reading. So we have these stations where we have this continuous deployment of seismometers, and we keep reading the seismic activity field through the seismometers. So normally, when an earthquake is about to hit, so you will see, so there will be some stress changes happening in the subsurface or at the focal point of the earthquake. So let's say where the earthquake is going to originate, there will be some stress changes, and those will kind of trigger some seismic waves. Or it could be, I forget what kind of waves it was, but I don't believe the detail is necessary here. But and then those seismometers tend to detect, tend to can record those kind of excitations. Now the so one thing that would be possible is like, and many people have been working on this, is like early detection of earthquakes. Let's say, like if an earthquake is going to hit in the next few minutes or hours, and then we would able to read from the data, like if an earthquake is going to detect. one of the challenges with currently is that, like reading, making sense of those signatures that we see in the data, and then relating them to the active to the actual physics. How do you know whether that's actually like a trigger warning for an earthquake, or is it just noise? And that also has to do with how we understand the physics of the earth and the earthquakes, right? So going forward, in order to solve this question, I believe that it will require both our capabilities of analyzing and mining the data, the seismic data that we have, and also our understanding of the physics. And I believe that coupling the two would be the way to go forward in order to predict earthquakes ahead of time before they do substantial damage.
Very interesting, Anshuman. Thanks for sharing.
Yep.
It'd be interesting to see how
Yep.
progress is made on predicting earthquakes. That would have a lot of impact positively on people. One other topic that you mentioned, I kind of want to get into a little more on, as you mentioned about decarbonizing the Earth. I'm familiar with X Prize. I don't know if you've heard of them. It's like a $100 million prize for carbon removal, and there's
Uh,
numerous techniques that people are looking at related to that on decarbonization. So when you mention decarbonization, like how do you imagine that working? Like what methodology were you talking about when you mentioned that earlier?
I'm not so I understand. I was The topic that I was touching upon was more about on the storage side. So I'm a earth scientist. So I was talking about how can you store the carbon in the earth. So I believe there are like different methods of like carbon capture. So I wouldn't presume to be an expert on that, but even if you are able to capture, say, huge amounts of data, where do you store that? And that was the problem that I was touching upon. And that's a huge problem. That's a huge problem. As I mentioned, you need to find the right spot. So I think the in the last global the climate change proceedings, we set a target of scaling up to the gigatons level of carbon capture and storage by the next decade or so, if I'm not wrong. And doing that, even if you are able to capture all the carbon from the air or from the vehicles themselves when they from their exhaust, there is this problem of storage. And you cannot just store carbon anywhere in the earth, because it's as a let's say, if you store it in a liquid form, it will tend to flow across the rocks. And then though that kind of flow can contaminate your water sources. So that's where I feel that this data, this seismic data and other kind of geophysical data can help us better come up with better storage sites for these huge amounts of carbon that we'll hopefully be able to capture soon. And then, because then we can be able to store this carbon and also track whether this carbon is flowing or not, whether it is contaminating any local useful resource. Did I answer your question correctly, or
Yes, I
please?
see. Okay, so it's all about storing carbon in the earth so it doesn't contaminate the surrounding structures. Makes perfect sense. Thank you.
That's awesome. Thank you so much for sharing. Ashima, this is really, really fun. Fun stuff.
Same here.
I've always been very interested in carbon capture. I was telling Todd while we were trying to have you on that an area of interest. Are you familiar with any of Elon Musk's work in this space? Because I know I'd been invited to one of those events on carbon capture and what they're attempting to do, be able to fix some of that problem. Is that something you're aware of? Just to extend on Todd's question.
I wouldn't say I'm like super familiar with Elon Musk's work on carbon capture, but maybe you can fill in. So, what are they like? Are they, because like in terms of like the goals of carbon capture? Like I remember from the carbon capture course I took during my PhD, one of the challenges was how you can capture this carbon, during exhaust of, say, like the waste gases, right? From whether it's like company, like a manufacturing company which is exhausting lots of exhaust fumes.
Hmm.
How can you carbon capture from those vents? Or even like small scale, let's say you are driving your car, how can it carbon capture from the exhaust? Is that one of the problems that they're
Yeah,
trying to
yeah,
solve?
exactly.
Okay.
Essentially, it's really that simple. Yeah, yeah. I think basically they've been working with this specific company just try to figure out how to capture carbon and stuff. And
Okay.
I think a lot of that is because of the rocket fuel and the
Yeah, yeah,
CO2 that,
yeah.
yeah. So
Yeah, exactly. So there's different solutions that people are exploring on. One of the interesting one that I was reading about recently, like ocean capture, like altering the pH of the ocean to
Yeah,
help make it so that it absorbs additional carbon.
Yep.
But they're really interested in any carbon negative solution because they feel like the totality of all of them could help, make the biggest impact essentially.
Yep.
yeah.
That's awesome. Yeah, so thank you so much, Anshuma, for joining us today. It was really fun, having you around. Do you have any concluding thoughts? I'm going to pass it to Todd.
Any other real world applications that you haven't really touched on that you kind of feel like would be ripe for, work in kind of your area of expertise with data science and AI and machine learning?
Yeah, I believe like I've had the opportunity to work with some very interesting problems, and like the kind of real world problems that we still face as mankind are like huge. Even in just the earth sciences domain, there are like lots and lots of problems. For example, let's say this kind of groundwater management problem that I was talking about, you can find different problems over there. Let's say, like how do you predict on the fly that how much someone would like to pump or not, and like in a way that makes sense, like with regards to sustainability of the groundwater system. There are other many other problems. I did not I have not had the chance to work on earthquake detection problems. I would that many people have been working on that, and that's something that really excites me as a researcher and as also a domain expert. Currently in my C3, like as a data scientist at C3, they have been working on supply chain industry inventory optimization and production schedule optimization, and like those are some of the applications I would be very interested to work on, and I believe that machine learning can make a contribution, like a positive impact in terms of solving the problems that we face. Yeah, I believe those are the list of problems, and not just like even like working at C3, I feel that while it is equally important to solve the unsolved questions, we also need to develop the tools and the software that is able to actually solve this problem. That is a very key part of any machine learning modeling and development. And I'm lucky to be working on that, and I hopefully will be able to make some positive contributions in that regard. So
Yeah. So I said, I think you bring up a very good point there because one thing I've seen, just in general, is that when you have a machine learning problem, right, the way the problem is converted into an actual business problem, or the way it needs to be structured to solve a business or to answer a business question is completely different. And it's really, really important to understand, like, some of the impacts of what data you're using. Now we're having things like
right.
responsible AI and inclusive AI and all of these different things that come into the picture as to, like, okay, how this particular model or training or classification or sentiment
Yeah.
or whatever, right, gets delivered to the client. And so you bring up a very good point. I think that it's really time for machine learning or data scientists to also kind of pay attention to, okay, how does this actually help to solve some of these life problems, and how do we develop solutions around them?
I totally agree.
Yeah, I completely agree as well. So yeah, it is interesting how there's a little bit of a divergence there, and you have to have business approach on these machine learning problems. It's a little bit different than necessarily the best approach for humanity, but really important questions we're talking about today. Really interesting applications and problems you worked on Anshuman. Really appreciate you taking the time to come on and share more about your work and the interesting areas that are ripe for potential in the future. Look forward to having you continue to make positive contributions in the space.
Thank you both. It was really fun chatting with you. I had a very nice morning. Great start to my day talking about machine learning. Yeah.
That's awesome. Thank you so much, Anshuma. We really appreciate you joining. We're definitely going to have you back because I think that the questions around the earth and how machine learning can actually help keep our lives safe It's really, really very interesting. There's something we didn't even get to, which is like SpaceX and some of the things that we're doing that are happening in the space, and how that relates to some of the things that you're doing or some of the work that you're doing as well. And so we're gonna definitely be having you back. We appreciate you joining. And to everyone who is listening in, thank you so much for joining another edition of our podcast. We're looking forward to talking to you soon. Have a wonderful day.
This has been the AI Innovation Space, sponsored by Ellumen. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Ellumen website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.